Yeah. Start.
Okay. Good morning, all. I am very glad to introduce the today's second session resource person, Dr. Sivasankar sir. Our resource person, Dr. Sivasankar sir, has completed his BE Computer Science and Engineering from Madurai Kamaraj University, ME Computer Science and IT from Manonmaniam Sundarnar University, Tirunelveli, Tamil Nadu, and PhD in CSC from Manonmaniam Sundarnar University. He has worked as lecturer in Raja College of Engineering and Technology, Madurai, and MEPCO Shellang Engineering College, Sivagasi, from the year 1998 to 2006. And also, he has worked as senior lecturer and system manager in MEPCO Shellang Engineering College, Sivagasi, from the year 2006 to 2007. He is presently working as an assistant professor at National Institute of Technology, Trichy. He has a total teaching experience of 23 years of undergraduate and postgraduate courses. He has published 60 numbers of research papers in various international conferences. He is a supervisor for 3 PhD scholars and 20 MTech scholars and 3 MS scholars. He has published his research papers more than 15 international journals. We are so glad that such an eminent person as the resource person for this session. We welcome you, sir.
Thank you, madam. Thank you for the nice introduction. Thank you, sir, for the opportunity given to me. Right. So let me uh, like share my screen, and I will teach you working with the regression analysis in today's class. Right. So regression is an predictive analytics technique. Right. So regression is a technique used in predictive analytics. So what do you mean by prediction? So prediction means based on the past data and current data, we are going to predict the future data using prediction. Right. So for example, you want to forecast the sales of a particular product. Right. So you want to forecast the number of products that is to be sold the next month. Based on the past several values and the current values, we can make a prediction, and like regression is form of a predictive analytics technique, right? So let me our agenda will be, we'll study about linear regression, multiple regression, logistic regression in today's class, right? So I will also show you how it is being implemented in I will also show you how regression analysis is implemented in R programming, right? So we'll try to solve some problems in linear regression. So the thing is that I will give you some theoretical foundations of regression analysis. We'll try to solve some problem in linear regression and logistic regression. I will also demonstrate how the code is being run, how to code it, and how to execute it in R programming, right? Right. To start with, right. So to start with, we'll have an intro about regression analysis. So basically, in regression analysis, we try to explain the influence between a set of variables, right? A set of variables, like we have a dependent variable and we have independent variable, right? The outcome variable is often known as dependent variable, since the outcome depends on other input variables, and the input variables are known as independent variables, right? So for example, you want to analyze the you want to predict the salary with respect to experience. So salary is going to be an output variable, or it's going to be dependent variable, and it depends on experience, right? So when the experience of a particular person increases, the experience and the skill set of a particular person increases, automatically the salary or income of a person increases, right? So in the case of regression analysis, we'll study linear regression and multiple regression first. So in the case of linear regression, there will be one output variable and one input variable, right? Whereas in the case of multiple regression, there will be one output variable and multiple input variables, right? So for example, linear regression, we are expected to predict the salary of a particular person with respect to only years of experience. It's known as linear regression, right? So you have one dependent variable is going to be salary, and the independent variable is going to be years of experience, right? So based on one input variable or one independent variable, you are going to predict one output variable. It's known as linear regression. Whereas in the case of multiple regression, again you have one output variable, but you have multiple input variables, right? So salary again can be predicted. Income of a particular person can be again predicted using multiple input variables like his academic background, like qualification, whether he's an undergraduate or a postgraduate, like his skill set, certifications. He has some certifications in a particular domain, right? And experience, work experience, right? So if and his age, right, and his performance metrics, right? So if you are going to have multiple input variables and one output variable, then it's known as multiple regression, right? So in today's class, we'll study in detail about this regression analysis. Here we assume that the output variables fits into some linear or logistic function, right? So in the case of linear function, the output will be like y equal to a plus bx, right? Y is going to be the dependent variable and x is going to be the independent variable. A is going to be the y-intercept and b represents the slope of the line respectively for that particular equation, right? So this can be modeled using regression analysis. So let me give you an example for regression analysis. For example, a manager wants to predict his savings at the time of his retirement, right? So you are working in an organization, you wanted to predict the savings at the time of your retirement based on the several past values and current value, right? So my first year savings was around 30,000, second year savings was around 50K, right? So based on several past values and current value, I can predict the future values in the case of regression analysis. So regression is of two types. Regression can be used for classification as well as prediction, right? So for example, regression can be used to answer the following type of questions. So what is a person's expected income, right? So like a person has 8 years of experience, his income is so and so. 5 years of experience, his income is so and so. What is a person's expected income with some 20 years of experience? Then it's known as linear regression, which is a classification problem. Sorry, which is a prediction problem. Whereas what is the probability that an applicant will be default, right? So a person applies for a home loan or any personal loan, whether the probability that a particular applicant is default. It's a classification problem. And right, so basically we have two types of regression: linear regression and logistic regression. So linear regression is used for prediction, and logistic regression is used for classification. So logistic regression is used to address the second problem, like what is the probability that applicant will default on a particular loan, whether his default is going to be is likely a defaulter or is likely to pay the loan, right? Yeah, he belongs to the low risk group or medium risk group or high risk group, can be addressed using logistic regression, whereas the first case can be addressed using linear regression, right? So let us start with linear regression. So linear regression is an analytical technique used to model the relationship between several input variables and a continuous outcome variable, right? So it is linear regression is used to model the relationship between several input variables. So you are going to have several input variables and one continuous outcome variable, right? And the key assumption is that the relationship between the input variable and output variable is going to be linear. So in linear regression, the key assumption is that the relationship between the input variable and output variable is linear, right? So this assumption appears restrictive. So it is often possible to transform the input or outcome variables to achieve a linear relationship between the modified input and outcome variables. Right. So we can we'll use a method of least squares to predict the outcome in the case of linear regression. Right. Use cases for linear regression. So what are the use cases of linear regression where it can be applied, right? So for example, a simple linear regression analysis model can be used to model the residential home prices as a function of living area, right? So whenever you build a home, based on the square feet, the engineer will fix the price, right? So if you want to build a house for 1,200 square feet, you will say 1,200 into 2,000 rupees per square feet. So it will be around 20 lakhs and 20 lakhs plus 10% again, 22 lakhs, right? Uh, so things will be fixed based on the square feet of construction, right? So a simple linear regression model is to model the residential home price as a function of the living area, right? So such a model helps us to evaluate the list of price of a home on the market, right? So if you are going to have one independent variable and one dependent variable, then it's known as linear regression, right? So here the dependent variable is going to be the price of your home, and independent variable is like what is going to be the square feet of the particular home, right? What is the size in square feet of a particular home, right? So here the input variable is going to be the size of the constructed area in square feet, and output variable is going to be the price of the particular home, right? So you can also extend it for multiple variables, right? The model can be further improved by including other input variables such as number of bathrooms, number of bedrooms, lot size, the particular school or district ranking, crime statistics in a particular region, and property tax paid in that particular region, right? So multiple regression means you are going to use multiple input variables again to predict one single output variable, right? So the multiple independent variables are going to be number of bathrooms in a particular newly constructed home, number of bedrooms, like crime statistics, right? So some regions are more prone to crime, right? Rural areas, whereas urban areas they are less prone to crime. And based on the district ranking, you can also predict the price of your plot, right? So in this case, since you are going to use multiple independent variables to predict one dependent variable, the price of the particular home, it's known as multiple regression, right? So the next use case is like demand forecasting, right? So business and government can use regression models to predict demand for goods and services, right? So for example, a restaurant chain can appropriately prepare the predicted time, type and quantity of food that the customers will consume based on the weather, day of the week, whether an item is offered as a special, the time of the day, and reservation volume, right? So both government as well as some private organizations, they can predict the demand for a particular product or service using regression. So this is an example for a multiple regression where we are going to predict the demand for a particular quantity of food, right? Right, you are expected to predict the demand for a particular quantity of food in a restaurant. So it's based on the day of the week, weather of the day, right? So weather conditions, if it is very sunny, like people may not come, or if it is raining, it may not come, people may not come, right? During normal days, people they tend to visit a restaurant. So based on the weather forecast, based on the day of the week, right? So weekends probably you have more visitors compared to working days, right? And whether a particular item is offered as a special, the time of the day where you are likely to have more number of people visiting the restaurant, and the reservation volume, you can build models to predict the sales of a particular product in a restaurant. So similar models can also be built to predict retail sales of a particular product in a supermarket, for emergency room visits and ambulance dispatches, right? So you can predict the day of the week You can predict based on the weather, day of the week, and time of the day, and reservation volume. You can predict the requirements for a particular product or a service. Right. So regression can also be used in a medical domain. Right. So it is used to analyze the effect of a proposed radiation treatment on reducing tumor size. Right. So doctors, they need to apply chemotherapy. They will apply some radiations on the tumors of the patients. So they can use it. They can use regression techniques to identify the level of radiation that has to be given to a patient. Right. So in this case, the input variables may include the duration of a single radiation treatment, frequency of radiation treatment, and the patient attributes such as age and weight. Right. So so you can identify the amount of radiation that has to be given to a particular person suffering with some tumor based on his age, based on his weight, right? Based on the duration, right? How many duration the particular person has to be given, and similarly, whether he has to be given how many times the frequency of radiation to be applied to a patient's tumor also can be determined using regression analysis. Right. So regression analysis, the regression model assumes that there is a linear relationship between the input variables and output variables. Right. So you can fit a straight line between the input variables and output variables. It is given by the equation y equal to b naught plus beta naught plus beta 1 x1 plus beta 2 x2 and so on till beta p minus 1 into xp minus 1 plus epsilon. Right. So this is an equation for representing multiple regression. So y is going to be the outcome variable, or it's the response variable, and xj represents x1, x2 till xj represents the input variable, and beta naught is the value of y when each of xj equals to 0. Right. So beta naught represents the y-intercept value, and beta j is the change in value, change in y based on unit changes in xj values, and epsilon is a random error term that represents the difference in the linear model and a particular observed value for y. Right. So epsilon represents. So in the case of multiple regression, you have a equation of this form: y is a response variable or outcome variable. Y is equal to b naught, beta naught plus beta 1 x1 plus beta 2 x2 plus till beta p minus 1 x p minus 1 plus epsilon. So epsilon is a random error. Y is going to be the outcome variable or response variable, and x1, x2 till xn they are going to be the input variables, and beta naught is the value of y. Right, beta naught is the value of y when x1 to xj are going to be 0. Right. And beta j is the change in y based on the unit change in the values of xj. Right. Right. So for example, you want to build a linear regression model that estimates a person's annual income as a function of two variables, right? Age and education, both expressed in years. Then we can model it using this equation. So the output variable is going to be income, family income, or income of a person with respect to age and education, right? So usually the person's income is likely to increase with age as well as with his years of experience. So how you represent it by means of an equation? So we are going to use a simple equation to represent it. Like income is an outcome variable. So income is an output variable. It's equal to beta naught plus beta 1 into age and beta 2 into education plus epsilon. So epsilon is a random error. So this two input variables, right, age and education, are the input variables that are used to determine the outcome variable that is going to be the income of a person. Right. However, we include this epsilon value because there is a considerable variation in the income levels for a group of people with identical age and years of education. Right. So there may be some difference with income for identical people with identical level of age and education, and that's represented by this error term epsilon in this model. Right. So right now we'll try to read something and we'll try to solve a simple linear regression problem. Right. So straight line regression involves a response variable. Right. Here the response variable is going to be y, and you have a single predictor variable which is going to be x, and a simplest regression model, linear regression, is represented by y equal to b plus wx, right? So y is going to be the response variable, x is going to be the predictor variable. So x is going to be the input variable and y is going to be the output variable. And in the case of simple linear regression, we are going to represent it by y equal to b plus wx, where the variance of y is assumed to be constant, and b and w, they represents the y-intercept and the slope of the line respectively, right? So the variable b represents the y-intercept and the variable w represents the slope of the line respectively, right? So the regression coefficients can be thought of as weight, and we can equivalently rewrite it as y equal to w naught plus w1x, right? So instead of y equal to b plus wx, we are going to modify and write the regression coefficients as weight values. So we are going to rewrite the equation as y equal to w naught plus w1x. Now, using the method of least squares, we estimate the best fitting line that minimizes the error between the actual data and the estimate of the line, right? So we can find out the value of W1 by using the method of least squares. So W1 can be calculated by using this formula, summation of I equal to 1 to d xi minus x bar into yi minus y bar divided by summation of I equal to 1 to d xi minus x bar whole square, right? So this is the formula used for calculating W1. So once you are able to calculate W1, you'll be able to calculate W0, and then you'll be able to fit the value for the equation y equal to W0 plus so voice is also right. So participants, I think you can note down this problem. This is problem we can solve to understand how linear regression works, right? So you have a person's years of experience. So x is a variable which is going to be an input variable, or it's going to be an independent variable. So based on the years of experience, right, we are going to predict, right? So based on the years of experience of a particular person, we are going to predict the salary of a particular person. This problem I have taken it from Giobbi Han and Michael Hamber textbook, Data Mining Concepts and Techniques, right? So it's a very simple problem. So you have years of experience. X is a variable that denotes the years of experience, and Y is a variable that denotes the a person's income in dollars, right? So a person 3 years of experience is going to draw a salary of $30,000 per year, and a person with 8 years of experience is drawing a salary of $57,000 per year, right? Our problem is to find the salary for a person with 10 years of experience, right? Right, given this training data, you are going to fit it into your model, right? Once you fit it into your model, a person with 10 years of experience, you are expected to predict the salary, right? Now, like the participants, I think you can calculate the mean value of x and mean value of y, right? How will you calculate the mean value of x? So mean value of x is going to be summation of x divided by n, total number of values, and similarly y, summation of y is, mean value of y is going to be summation of y divided by total number of samples, right? So totally here we have 10 samples, right? 3, 6, 9, 10 samples. So you are expected to find 3 plus 8 plus 9 plus 13 plus 3 plus 6 plus 11, 21, 1, 16. So you are going to sum the value of x and find the mean value of x. Similarly, you are going to sum the values of y and find the mean values of y respectively. right? So the value of x mean and y mean are going to be 9.1 and 55.4 respectively for this data. You want to note it down and you can work on this simple problem. So I will teach you how to run this problem for any type of data set using R programming, right? So I think you can note it down. It is like we have it only for 2 or 3 slides, and you will be able to make it, right? So this is a sample data, right? And so the mean value of x is going to be summation of x by n, which is going to be 9.1, and the mean value of y is going to be summation of y by n, which is going to be 55.4, right? So now you are going to calculate the value of W1 using the method of least squares, right? Method of least squares, you know the formula, right? Summation of xi minus x bar into yi minus y bar divided by summation of xi minus x bar whole square, right? So I have given you the formula for computing the value of W1 in the previous line. So W1 is computed using summation of xi minus x bar into yi minus y bar divided by summation of xi minus x bar whole square, right? So in this case, so like 3 minus xi minus x bar is going to be 3 minus 9.1 into 30 minus 55.4, right? So it's going to be xi minus x bar into yi minus y bar. We are going to repeat it, 8 minus 9.1 into 57 minus 55.4 and so on, and the denominator it's going to be xi minus x bar whole square, right? So it's going to be 3.3 minus 9.1 whole square plus 8 minus 9.1 whole square till 16 minus 9.1 whole square, right? So once you compute the value of W1, right, how will you calculate the value of W0? So W0 is going to be y minus W1 into x, right? So you know the equation, right? So once you calculate the W0 value, how will you calculate the value of y? Sorry, once you calculate the W1 value, how will you calculate the value of W0? So W0 value is going to be y minus W1 into x. So you know the value of y. So the y mean value is going to be 55.4, and right, W1 value is going to be 3.5, and x mean value is going to be 9. Is going to be 3.5 respectively. Now you have this equation, right? So you have your equation y equal to w 3.5 into 10, it's going to be 35. So it's going to be a person with 10 years of experience is likely to draw a salary of $58,600, right? So hope you can understand this problem, right? So I hope that you can understand this problem, right? The things are very simple. So given some x value and y value, right, you are expected to calculate the mean value of x and y respectively, right? Mean value of x is going to be summation of x by n, and mean value of y is going to be summation of y by n. You calculate the mean value of x and y respectively. Then you are expected to calculate the slope of the line. Slope of the line W1 is calculated by means of the method of least squares, which is given by summation of xi minus x bar into yi minus y bar divided by summation of xi minus x bar whole square. So right, so for all the values of x and y given in the training data, you are going to use it to find the slope of the line. So it's going to be summation of xi minus x bar into yi minus y bar divided by summation of xi minus x bar whole square, right? So once you find the value of W1, you will be able to find the value of W0, right? So W0 is equal to y minus W1 into x, right? So W0 is computed by finding y minus W1 into x. So once you get the values of W0 and W1, you are going to fit it into the equation, linear equation, y equal to W0 plus W1 x, right? So here you have only one outcome variable or only one dependent variable, right? So the dependent variable or the outcome variable is going to be salary of a particular person, and the input variable or independent variable is going to be the years of experience of a person, right? So we are going to represent it by y equal to w naught plus w1 into x. So once you substitute the value for w naught, so regression analysis is a statistical tool to establish a relationship between two variables. So you have two variables. One is called a predictor variable, whose value is gathered through experiments, and the other variable is called response variable. Right? So y is going to be the response variable, and x is going to be the predictor variable, whose value is gathered